Hello everyone, welcome to my YouTube channel. As you all know that myself I am Gangotri. Today I am going to explain the topic of kruskal algorithm. Kruskal algorithm definition. Kruskal algorithm is a greedy algorithm used to find the minimum spanning tree (MST) of a connected, weighted, undirected graph. A minimum spanning tree is a subset of the edges that connects all the vertices in the graph without any cycle and which is the minimum possible total edge weight. Greedy approach. Kruskal algorithm always selects the edges with the smallest weight that does not form a cycle in the MST being built. Disjoint set union or union find. Data structure is used to efficiently manage and merge connected components and detect cycles. Steps of kruskal algorithm. First, we need to sort all the edges in the graph in the non-decreasing order of their weights. For example, here all the weights should be converted into a non-decreasing order. Initialize MST as an empty set with no edges. For each edge in the sorted list, check if the including the edge in the MST forms a cycle. If it forms the cycle, we should avoid it. If no cycle is formed, add the edge to the MST. Repeat until MST as V minus 1 edge, where V is the number of vertices. Always the edges should be less than the vertices and it should be minus 1. Data structure used. Edge list. To store all the graph edges. Union find, a disjoint set which is used to check if two vertices are in the same connected components or not. Here A, B, C, D, E are the edges, 1, 2, 3, 4, 5, 6, 7 are the weights. And AB, if AB is connected with by the weight 3 and AE will be connected by the weight 1, BC will be connected by the weight 5, BE will be connected by the weight 4 and CD will be connected by the weight 2, ED will be connected by the weight 7, EC will be connected by the weight 6 and these all connections should not form the any cycle. Time complexity. Sorting edges O of E log E, O of E by log E, O of E log E. DSU operations O of E alpha of V, O of E divided by C dot of alpha of V, O of E dot alpha V, where alpha is the inverse function almost constant. Total O of E log E, O of E by log E, O of E log E, where E is the number of edges and V is the number of vertices. Cycle detection. Kruskal algorithm must avoid cycle while selecting the edges. This is achieved using the union find data structure. Find operation checks which set a node belongs to. Union operation merges the two disjoint sets. Both operations should not form the any cycle in this whole process. Applications of kruskal algorithm. First, network designing. Designing least cost telephone, computer or electrical networks. Approximation algorithm used in some traveling salesman and clustering algorithms. Civil engineering, planning efficient roads, railways and pipelines to minimize the construction cost. Image processing for region-based segmentation or edge detection in images. Social networks identifying connected communities or minimal ways to connect the groups. Properties of kruskal algorithm. Greedy algorithm always makes a local optimal choice in hopes of finding a global optimum. It always chooses the local choices only. Safe edge property. The next edge added is always safe, that is, it does not form a cycle and maintains MST property. Works for disconnected graphs to form a minimum spanning forest, a forest of MST for each component. Disadvantages: not suitable for the dense graphs compared to Prim's algorithm with a Fibonacci heap. Needs sorting of edges which might be costly for large graphs. Thank you.